Yeah. Good afternoon, everyone. I'm Dong Liang, and I come from the University of Hong Kong. Today, my topic is about my presentation topic is about 40 point cloud driven real time monitoring of construction mobile cranes. Next, I will introduce my research from the following 5 parts. First, mobile cranes are important and common equipment on the construction site. There are two kinds of cranes. The first is the tower crane, and the second is mobile crane. Yeah, uh, my research focuses more on the mobile crane. It has the following characteristics, like high mobility, relative low height, and face more complex environment, etc. Uh, things. Well, for mobile cranes, we the reason why we need to pay more attention to it is that we always fixed a lot of monitoring devices on the uh, tower cranes since it always has a fixed location. But for the mobile cranes, as I stated before, it has a more high mobility. So it is not to monitoring this one. Digital twin is popular these years in the construction industry in order to um, better to monitoring, simulate and control the mobile crane on the construction. I guess the digital twin mobile crane is a good choice. Digital twin is a combination of a computational model and a real-time system designed to monitor, control, and optimize its functionality. And in order to achieve digital twin mobile crane, I guess 4 parts need to be included. First is the digital representation. The second is sensing technology. Third is data integration and analytics. The four is interaction with between the virtual environment and physical environment. Well, uh, the reason why we need to develop digital twin mobile crane is from safety concern, productivity improvement, and some operation assistance. Well, there are some benefits of digital twin mobile crane, just like the motivation. Well, in order to achieve digital twin mobile crane, we need to satisfy following requirements like real-time accurate and high precision sensing or monitoring. The second is when we get sensing or monitoring data, we need to develop feasible semantic registration method of sensing data. The third is the effective simulation method. It's not the focus of my research. Well, the current gap of digital twinning mobile crane is the last lack of a convenient, fast, and reliable sensing method, and automatic semantic registration method. Or we can see just the first stage to develop digital twin mobile crane is the just we need to develop a good method to monitoring or sensing uh, the mobile crane and process the sensing data. Well, for the 4D point cloud, maybe most of us are familiar with 3D point cloud. It consists of a three-dimensional collection of data and point or coordinate. The 4D point cloud just adds the time. So it's always be applied to some real-time application like autonomous driving. For the 4D point cloud, its strength is obvious, like it is real time, and also cover precise geometry uh, dynamics. Also, it has some good, it has some strengths of 3D point cloud, like better adaptability in poor visibility environment, also providing localization and mapping information. Also, it is easy to carry out multi-view fusion. This is important for construction site since it always large, so we need multi-sensors to do these things. The last is it has a lower cost. Well, next part is literature review. First, we review some mobile crane sensing application. Yeah, for the mobile crane sensing or monitoring application, there are generally three purposes. The first is the crane pulse estimation, and second is object detection in working area of mobile crane. The third is load survey and rotation estimation. These studies also could be divided according to the sensing method. There are generally three kinds. The first is the IoT sensors. The second is CCTV cameras. The third is we can see the static lasers ladder to scanning some static environment. Yeah. Also, we conclude the performance comparison from this literature. We could see the 4D PC ladder have a better performance in most requirements, like the mobility. It is important since the mobile crane are always move in the construction site, so we cannot just fix the sensors. Well, next are some existing literature on 4D point cloud. Well, it should be noted that all based on deep learning methods. Just finishing some assignment like 3D object detection or 3D action recognition. Facing in order to achieve the monitoring or sensing mobile crane, facing the challenges now like limited data site, construction scenario, and spatial-temporal data structure, and also multi-source data. We proposed the following technical route. The first is to fuse or register the multi-view data, and then we remove the environment. The next we cluster we conduct clustering for the data, and then to search the possible component according to the 3D models, to use the optimization to search if there is a possible component in the construction site. It is assumed that we already have all 3D models of objects on the construction site. Well, we just search it every seconds. Well, also the left part is to accelerate this process. Just in the next second, we could first remove the existing component. Well, we conduct a case study in a project. It is a pedestrian bridge with steel structures. This project have following characteristics like night construction, fast construction. Also involved hosting activity. Also mobile machineries participate this project. Also involved some people. We designed a 4D PC LiDAR system to monitoring this project. Well, the data match is the LVX, and it includes XYZ and time, data. Well, this is a preliminary analysis result. We could see that we could capture the possible component like the steel beam and vehicles. This is the analysis result of the beam 2. We could see the first move between the 4 minutes and 16 seconds and end at 5 minutes and 56 seconds. In the right corner, we could see the final stage of beam 2 and also the trajectory of the whole trajectory of the beam motion. This is the motion, and also according to the result, we could get the rotation, and we could see the component generally keep horizontal. Well, this is beam 1, the same as similar as beam 2. We could got the location and also the rotation. The final is we could detect the object like the vehicles in the working area of mobile crane. We could know their move and enter and leave. Conclusion, yeah, from the according to the proposed method, we could get the semantic information of 4D PC data and the load motion and the rotation hoisting activities of mobile crane could be captured. The next is objects such as vehicles within the working areas can be dynamically monitoring. Based on both, we could conclude that some monitoring or operation system could be established for mobile crane. In addition, the applications for the PC can be extended to construction safety and site management. The main limitation of this study is that the assumption that we already know the 3D models of all object potential existing in the construction site. Well, this is a reference in the study. Thank you.